is used by buildings, but it means electrical consumption, gas consumption, diesel consumption, total electrical consumption is consumed by buildings. That's why, and this is our baseline. So it means that if we can save 10% from minimum, like 10% of this energy consumption that goes on all buildings worldwide, so we are resolving this problem globally, reducing globally 5% energy consumption. But this percentage can be higher, it can be 20% or even more. So it means just by working on buildings and on buildings' energy efficiency, we can reduce global energy consumption from 4 to more than 10%. And what is very, very important, life cycle cost of the building. 80% of total life cycle cost are coming during operational phase, so of total life cycle cost. It means CAPEX and OPEX. So CAPEX is 20% from total, only 20% from total operational cost for the building. Everything else goes to maintenance and to energy consumption. This is a huge number. Let's go back, sorry. So, and here in this region, 50 to through energy reduction, as well there are other savings through extended equipment lifetime. Again, so equipment will work during longer period of time. No need to replace equipment. No need to have carbon. So we are delaying carbon emission for manufacturing and installing and commissioning of new equipment, and as well it can provide significant operational cost from point of maintenance, where involvement of people for maintenance will be lower, and as well there is associated carbon emission due to maintenance activities. So as well, new revenue streams, so new trends are to produce and to sell carbon offsets. So if a new trend will be, so now we want to achieve net zero. We want to achieve this balance that was on our planet before 70-60. So some industries that they cannot achieve it. We don't want to stop our civilization. We don't want to stop our industry. We want to have sustainable growth. But some industries will not be able to achieve this net zero. But on the other hand, some industries, some buildings can overachieve, so they can actually have higher absorption comparing to emission of CO2, and they will have those carbon certificates that they can sell to the industries that cannot be carbon neutral. As well, this has now a huge impact on reputation and increase in competitive advantage. So this competitive advantage, it comes through ESG, through factors, through environment, social and governance sector, where this environment is very important, and this will be a key factor for investments. So now to show now in practical way what is digitalization in energy efficiency, and I want to show it. So basically, digitalization in energy efficiency, as we said, is in one word, it is creating of the mathematical models, digital models that can actually analyze, that can simulate a process that is happening in a factory, in the building, and each and every process. Why? Because this is the easiest way to make a decision. For example, you want to make decision for improvement of your production process. It requires certain investment. To make this decision, should we go with this investment? It is always better to test it. So it can be tested in this digital environment. So if we create digital models of our processes, of our buildings, we can test any scenario, we can predict what will happen, and this will help us to make this decision. So, for example, if we look at the car manufacturing industry, so safety is the most important parameter in car manufacturing industry, and safety of passengers and driver. So there are crash tests. So before a CFD and before final element analysis, so there were many crash tests to come to point that car is safe. It means that huge cost start to implement solutions to reduce this energy consumption. And there are different solutions like demand flow for chiller plant optimization. There is demand flow, actually this demand flow is globally for HVAC optimization, chiller plant optimization, and air side optimization that can reduce power consumption up to 30%. There is huge consumption that is coming from the diesel consumption on boilers because heat is required. So what we can do, we can convert those boilers to biodiesel. So this is sort of renewable. So biodiesel, so this actually carbon footprint was counted for this vegetable oil that was produced. So biodiesel has zero carbon footprint. And then and then there are some other measures, and then we come to a point where this net zero will be achieved by installing of the only 30% of the only 30% of the initial capacity of the actually the demand for energy. If you look at equivalent of the electrical consumption, because diesel consumption and other utility consumption we are converting to electrical, so to find electrical equivalent.